On the 1st of August, meteorologists watching the tropical Pacific were tracking a strong, rapidly intensifying El Nino. By the 2nd of August, they were tracking something else entirely. During that single week, Australia's Bureau of Meteorology confirmed that the key ocean temperature index used to measure this event had climbed to +2, 0.2 degrees Celsius, crossing the 2-degree line that separates a merely strong El Nino from what scientists classify as a very strong one, the tier the public usually just calls a super El Nino. It's the first time that specific weekly index has broken above 2 degrees since February of 2016, the tail end of the last event powerful enough to earn that label. 10 years. That's how long it's been since the ocean did this. To put that gap in perspective, think about everything that's happened globally in the 10 years since the ocean last crossed this exact line. An entire decade of hurricane seasons, wildfire seasons, and winters unfolded without this specific ocean signal in the picture. An entire generation of new homeowners, new farmers, and new coastal residents settled into communities without ever having lived through what a very strong El Nino actually does to the weather above their heads. That's part of why crossing this threshold again matters enough for a dedicated breakdown. It's not a routine seasonal update. It's the return of a climate driver powerful enough to reorganize weather patterns across multiple continents at once, arriving for the first time in most people's recent memory. Today, we're breaking down exactly what that number means, why crossing it matters, how the tropical Pacific got here so quickly, and what the actual forecast models, not speculation, are saying comes next. Because a headline like El Nino crosses a critical threshold can sound abstract until you understand what's actually being measured and why the scientific community treats this specific line differently than the ones before it. Quick note before we get into the data: subscribe if you want every update on this event as it develops. It's free and it helps a lot. And drop a comment letting me know where you're watching from, because depending on where that is, what comes next in this video may affect you directly. Let's start with the number itself, because 2 degrees needs context to mean anything. The primary tool scientists use to track El Nino is something called the Niño 4 index, a measurement of sea surface temperature anomalies across a defined stretch of the central and eastern equatorial Pacific Ocean. It's not measuring the actual temperature of the water, it's measuring how far that temperature has drifted from the historical average for that specific week of the year. Climate agencies around the world use this same basic index, but apply slightly different thresholds to classify strength. Under the standard most commonly used by NOAA's Climate Prediction Center, a weak El Nino sits between half a degree and just under 1 degree above average. A moderate event runs from 1 degree up to 1.5. A strong event spans 1.5 up to 2 degrees. And a very strong event, the tier most people mean when they say super El Nino, requires the index to reach 2 full degrees above average or higher. That's the line this event just crossed, and crossed with room to spare, landing at 2 degrees during the week, ending August 2nd. It's worth being precise about what crossing actually means scientifically, because a single strong weekly reading isn't the same as an officially confirmed very strong El Nino. Agencies like the Bureau of Meteorology and NOAA don't classify an event's overall strength off one data point. They require the index to remain above a given threshold for an extended sustained period, typically averaged across overlapping 3-month seasons, before formally assigning that classification to the event as a whole. So this milestone is exactly that, a milestone, real, meaningful, and worth covering. But the sustained official confirmation of a very strong El Nino for this entire event still depends on the index holding above that line for months to come, not just one impressive week in early August. Here's why the forecast community is confident it's going to do exactly that. NOAA's Climate Prediction Center issued its own update just 1 day before that Bureau of Meteorology milestone, confirming on August 3rd that El Nino is present and actively strengthening across the central and eastern equatorial Pacific. Using their own metric, a slightly adjusted version of the raw index called the Relative Oceanic Nino Index, which factors out some of the broader background warming trend affecting the entire tropical ocean, NOAA is now placing the odds of a very strong event during the October through December window at 81%, a sharp jump from 63% in their previous outlook just weeks earlier. They're also giving this event an 88% chance of reaching at least strong intensity, and a 97% chance of persisting all the way through the early part of next spring. Independent modeling from Columbia University's International Research Institute for Climate and Society backs this up almost exactly. As of their most recent Quick Look report, 23 out of 26 separate forecast models are now projecting a very strong El Nino, defined the same way, at or above 2 full degrees, when this event peaks during the October, November, December period. It's worth pausing on that distinction between the Relative Oceanic Nino Index and the conventional weekly Niño 3. 4 reading because both numbers get reported and they don't always match, which can understandably cause confusion. The conventional index is the raw sea surface temperature anomaly exactly as measured. The relative version, RONI, takes that same raw number and subtracts out the broader warming trend affecting the entire tropical ocean basin as a whole, not just the El Niño region specifically, essentially isolating El Niño's own distinct signal from the general background warmth the whole tropical Pacific has been carrying in recent years. As of the most recent weekly comparison, the conventional Niño 3, 4 index was running around 2, 3 degrees, while the adjusted RONI value sat closer to 2, 0 degrees for that same week. Neither number is wrong. They're simply measuring slightly different things, and serious forecast agencies increasingly favor the RONI approach specifically because it makes El Niño events from different decades more fairly comparable to each other. A fast-warming planet doesn't just make new El Niño events feel stronger, it can make the raw numbers look stronger too, whether or not the underlying event actually is. So how did the tropical Pacific get here this fast? The honest answer involves a specific documented mechanical trigger, not just vague ocean warming. Back in the spring, an unusual cluster of tropical cyclones formed in the western Pacific in rapid succession, a genuinely rare triplet according to climate scientists tracking it at the time. That cluster of storms generated a burst of unusually strong, persistent westerly winds blowing the opposite direction from the trade winds that normally dominate the tropical Pacific. When winds reverse like that, even temporarily, they physically shove the warm water that's usually piled up near Indonesia back toward the east, exactly the mechanism that gets an El Niño started and then accelerates it once it's underway. Climate researchers flagged this specific westerly wind burst back in early April as a strong reinforcing signal behind the eastward-moving Kelvin wave already forming beneath the surface. From there, the numbers climbed with genuine speed. The World Meteorological Organization's tracking shows the Niño 3, 4 anomaly rising from half a degree in April to 9/10 of a degree in May to 1.6 degrees by June. By mid-July, the weekly index had already reached 2, 1 degrees according to IRI's tracking, and by early August, it had cleared the 2-0 threshold on the Bureau of Meteorology's measurement as well. That's roughly 4 months to go from a borderline weak event to a very strong one, a genuinely fast trajectory by historical standards. That speed is exactly why comparisons to the past 2 events capable of reaching the same tier keep coming up. There have only been 2 El Niño events in the modern satellite record widely recognized as reaching very strong intensity, 1997 into 1998 and 2015 into 2016, the same event referenced by that 10-year gap we opened with. Both of those became historical benchmarks, reshaping global rainfall patterns, fueling devastating wildfires across Indonesia, and contributing to major swings in global temperature records during their respective years. The 1997-98 event is still the reference point meteorologists reach for first, contributing to catastrophic flooding across parts of South America and helping push 1998 into the record books as the warmest year measured on Earth up to that point. The 2015-16 event, the more recent of the two, produced a winter across North America that diverged sharply in several regions from what forecasters had expected going in. A reminder that even a well-forecast, very strong El Niño can still deliver regional surprises once it actually arrives. According to trackers comparing this year's ocean data directly against those 2 historical events week by week, the current trajectory is running ahead of both of them at this same point in their development. That doesn't guarantee this event will ultimately surpass either one by the time it peaks. Ocean behavior can still slow down, plateau, or even reverse course before reaching its final strength. But it's the reason forecasters are treating this milestone with more seriousness than a routine seasonal update. Before we go further, it's worth including a caveat NOAA itself has been careful to state directly, because it's honest and it matters. A stronger El Niño does not automatically produce proportionally larger weather and climate impacts everywhere it reaches. Greater ocean strength raises the probability of a range of downstream effects, an amplified jet stream, an altered storm track, above average temperatures across a wider stretch of the globe, but it does not mechanically determine the exact magnitude of what happens in any specific city or region. The relationship between ocean strength and ground level impact is a probability shift, not a guaranteed multiplier. That distinction is worth holding on to as we walk through what actually comes next. So, what does come next, now that this specific threshold has been crossed? In the immediate term, over the next several weeks, expect the sea surface temperature anomaly itself to keep climbing. The World Meteorological Organization's own multi-model forecast has the Niño 3. 4, mean rising further through the August to October window, continuing its climb toward the projected October through December peak. There's also a second ocean pattern worth watching alongside it. A positive Indian Ocean dipole has been developing in tandem, measured at +0. 63 degrees, as of the same early August window, with models suggesting it could strengthen further by September. When a positive Indian Ocean dipole develops alongside a strong El Nino, the two tend to reinforce each other's downstream effects rather than simply adding on top of one another, which is part of why the World Meteorological Organization has specifically flagged the combination as a driver of intensified drought, flooding, and wildfire risk in multiple regions simultaneously over the coming months. For the Atlantic hurricane season, the near-term effect of crossing this threshold is continued suppression. A strong to very strong El Nino reliably increases wind shear across the Atlantic's main hurricane development region, the stretch of ocean between Africa and the Caribbean responsible for producing most of the season's most dangerous long-track storms. That elevated shear has already been showing up directly in this year's data, and it's the primary reason NOAA and Colorado State University have both been steadily revising their seasonal hurricane forecasts downward as the summer has progressed, now projecting one of the quieter Atlantic seasons in recent memory. That pattern is expected to hold and likely intensify somewhat as the underlying ocean signal it's built on continues strengthening toward its own peak. It's worth repeating the caveat that comes with every quiet season forecast. A below-normal seasonal outlook describes the basin as a whole, not any individual storm's path or strength, and officials tracking hurricane season every year are consistent in warning that it only takes one landfalling storm to make an otherwise quiet year a genuinely bad one for the community it hits. Moving into fall, expect the atmospheric response to this ocean signal to become considerably more visible across North America and beyond. As the Pacific Ocean anomaly climbs toward very strong territory, it increasingly locks in what meteorologists call an atmospheric standing wave, a persistent zone of rising air and low pressure anchored over the tropical Pacific by the sheer strength of the anomaly beneath it. That standing wave amplifies the Pacific jet stream, and the downstream effects of that amplification show up as a fairly consistent, well-documented pattern across the fall months. Continued warmth holding across the northern United States and Canada, a more active, wetter storm track settling in across the southern half of the country, and drier conditions persisting across the Pacific Northwest and upper Midwest. Europe's fall response tends to lag North America's by several weeks, but as this event continues strengthening, expect a similar signal to eventually emerge there too. Warmer, more westerly flow-dominated conditions across the central and western continent, paired with increased autumn rainfall pulled in off the Atlantic. Beyond North America and Europe, the World Meteorological Organization's broader seasonal outlook, issued specifically in response to this strengthening event and the positive Indian Ocean dipole developing alongside it, points to above-average temperatures as overwhelmingly likely across most of Africa, the Arabian Peninsula, the Indian subcontinent, Eastern Asia, Central America, the Caribbean, Southern Africa, most of South America, and New Zealand through the remainder of the year. Australia's own Bureau of Meteorology, the same agency that flagged this week's threshold crossing, has separately warned the country to brace for an unusually dry early end to what remains of its winter, driven by that same combination of a very strong El Nino and a strengthening positive Indian Ocean dipole working in tandem. It's a genuinely global story, and this week's threshold crossing is the clearest single data point yet that the event driving all of it is not slowing down. Winter is where crossing into very strong territory carries the most weight, because the relationship between event strength and winter jet stream disruption is genuinely nonlinear. Research comparing moderate El Nino winters against strong and very strong ones has found that moderate events produce a relatively gentle ripple in the upper atmosphere, while very strong events trigger a considerably sharper, more forceful reshaping of the jet stream, driven by how deep the Pacific Trough carves in and how powerfully the corresponding ridge builds over Canada in response. Multiple long-range forecast models are currently projecting a split flow pattern for the winter of 2026 into 2027 as a direct consequence of this event's strength. A ridge of high pressure over Canada, suppressing the harsh, snow-heavy winters of the northern plains, upper Midwest, and Great Lakes are more typically associated with, paired with, an unusually active, occasionally sharply cold storm track, shifting instead into the central and southern plains and the interior mid-Atlantic. If this event does sustain very strong intensity through the winter, as the current model consensus increasingly expects, that split flow signature is likely to become more pronounced, not less, as the season progresses toward its own January and February peak. That split flow pattern is also part of why very strong El Nino winters tend to produce so much regional disagreement in how people remember them afterward. Ask someone in Seattle or Minneapolis how the winter of 2015 into 2016 felt, and you'll likely hear about a milder, quieter season than usual. Ask someone in Texas or across the Gulf Coast the same question, and the answer often skews toward an unusually active, storm-prone stretch instead. Both memories are accurate, because a very strong El Nino doesn't produce one uniform national winter. It produces two distinctly different regional winters happening simultaneously, separated by that shifted storm track. If this event does peak at very strong intensity as currently projected, expect that same regional split in how this winter eventually gets remembered too. It's worth restating the honest scientific position on all of this one more time before we close, because it's easy to slide from "here's what the models project" into treating it as a locked-in certainty. Every forecast we've just walked through carries genuine quantified uncertainty, expressed in the actual percentage figures the agencies themselves publish: 81% for a very strong peak, 88% for at least strong, 97% for the event persisting into spring. Those are high confidence numbers by seasonal forecasting standards, but they are not 100%, and NOAA's own caution about strength not automatically dictating impact magnitude applies just as much to the winter outlook as it does to this month's headlines. What we can say with real confidence is that the ocean signal driving all of it just crossed a threshold it hasn't crossed in a decade, that the trajectory getting it there has been unusually fast, and that essentially every major forecast center tracking it right now is pointing in the same direction. Stronger before it's weaker, with the real climax of this event still roughly 2 to 4 months away. So here's the grounded version of everything we just covered. On August 2nd, the benchmark index used to measure El Niño crossed 2 full degrees above average for the first time since February 2016, officially entering very strong territory on a weekly basis, even if the fully confirmed seasonal classification is still developing. It got there in about 4 months, propelled by a rare burst of reversed trade winds back in the spring, and it's now on a trajectory that multiple independent forecast centers agree is likely to keep climbing into a peak sometime around November. Along the way, it's already reshaping hurricane season, and it's on track to reshape the coming fall and winter across a large stretch of the globe, with the size of that reshaping directly tied to just how far past this threshold the event ultimately climbs. If you want to keep an eye on this yourself between now and our next update, a few specific numbers are worth bookmarking. Watch the weekly Niño 3, 4 index for whether it holds above 2 degrees in the weeks ahead, rather than this being a brief 1-week spike. Watch NOAA's monthly ENSO diagnostic discussion, typically released in the first half of each month, for any change to that 81% very strong probability figure. And watch the positive Indian Ocean dipole reading alongside it, since its own trajectory toward or away from strengthening will meaningfully shape how intense the combined global impact of both drivers ends up being together. None of those require any specialized background to check. They're published openly by NOAA and the Bureau of Meteorology on a regular schedule, and they're exactly the numbers separating this week's milestone from a confirmed, sustained, very strong El Niño over the months ahead. We'll be tracking this index every single week as it climbs toward its projected peak, and we'll bring you the next update the moment the data shifts in either direction. Subscribe if you want that followed in real time, and let me know in the comments what part of this event you want broken down next. The hurricane season angle, the winter outlook, or the historical comparison to 1997 and 2015. See you in the next one.